Any questions on the chapter? Cool. Okay, so up until this point, we've talked about everything that's necessary to build a program that solves any problem that computers can solve. We talked about sequence, selection, iteration. We talked about objects. We talked more about objects. And now this class, I think, is crucially important in order to have a basis in Java that means that you can solve, you can actually solve most problems that you would want to solve. Arrays make things a lot easier, especially when you're dealing with lots and lots of data. And computers are really good at dealing with lots and lots of data, so most of the programs that you end up writing deal with data. They are also the main link between intro Java and CS 1450 data structures. Arrays provide a way of storing a bunch of data, and then in data structures you learn how to basically create objects that are wrappers around arrays that allow you to interact with them in specific ways. So, starting at the beginning, what are arrays? Arrays are basically a sequence of data. You can have arrays of primitive types, you can have arrays of objects, and no matter what your array, no matter what base type your array is of, they operate exactly the same way. So let's it feels weird. Half the room's empty. Fun with arrays. Let's start with declaring an array. When we declare a variable, we can call it something like a scalar, a single value. We have a variable declaration like int a. And that declares a variable that can store a single integer value. This actually does two steps. It says, from this point onward, there is a variable called a of type integer, and it also provides some space for that integer value to sit in memory. When we declare arrays, those two things are not necessarily, they don't necessarily happen at the same time. So if we want to create an array of ints, let's start with what we know, array of ints. But as we just mentioned, that creates a single place in memory that stores a single integer. In order to make this an array, we simply add square brackets to the type. Now, that only does the first part of a variable of a normal variable declaration. It says there is a name, a variable called array of ints that is of type array of ints. That is of type int array. The square brackets indicate that it's an array, and the part before the square bracket is just like any other type. it indicates the type of each element in this array. But Java doesn't actually set aside any space for this array, mainly because it doesn't know how big it is. All we're saying here is there is an array. It doesn't say where this array is. It doesn't say how many elements this array contains. In fact, if we do this, well, yeah, sure. It doesn't actually let us compile. If it did, array of ints would simply be null. It is just like creating an instance of an object or creating a variable of an object type, of a class type, also called a reference type, and not actually setting it to anything, not actually creating a new object to store there. So it essentially points to null. Java is kind of helpful. I would say smart, but not always smart, is helpful about that. And if you haven't set a reference variable to some value, it says you might not have. And actually, it does it with primitive types as well. If you create a variable and don't actually give it a value, it says this might not have an actual value. So wherever you're using it might not make sense. So at this point, in theory, on line 5, we actually have no idea what is stored in array of ints. It's absolutely meaningless. We haven't stored anything in array of ints. But we don't have that issue with A. Because with A, I think it'll still give us the same error, but we can set it to 0. A already has some place in memory. But array of ints doesn't, and that's potentially dangerous. So how do we give it some value? Tell it that it resides someplace in memory, has some size. This syntax looks very similar to creating an instance of an object. We use the new keyword, but instead of following it with the name of a class, which implicitly calls its constructor, it still looks kind of like the type. This is not an object, so there are no parentheses because we're not actually calling it a constructor, but we do need to specify some size here. So we can do something like that. Specify that it has size 8. And now we can compile it, and we can run it, and it prints out some nonsense. In this printout, this left square bracket actually means it's an array. This I means that it's an array of ints, and then it is followed by the standard @ and then the actual reference. Which means that arrays, just like objects, are reference types. So they behave just like every other reference type. So if you try to see if two arrays are equal to each other, it does not compare them element by element. It compares their references. And the book talks about that in one of these sections. I think in the array details part of 7.1. So it's just like if you were to compare two strings using the equality operator, the two equal signs next to each other. Arrays, however, do not have a dot equals method like strings do. Arrays are reference types but not objects. They do not have methods. With one notable exception, they do not have properties, but they are not primitive types. They are still reference types, as evidenced when you try to print one out. That notable exception is the property length. So lots of objects have a size method. Why they chose a different name for this property, I don't know, but the property is length. And it tells you exactly how many elements are in this array. So arrays have a fixed length. You can't change the length. If line 5 were to print out anything other than 8, I would start to be worried. Length will always be identical to the length that you specify between the square brackets on line 4. So if we compile and run this, it will print out 8. But that's really not very interesting. Great, we can create arrays, we can print out their length, we can get their length. The power of arrays is, as previously mentioned, the ability to store multiple values in, I wouldn't say the same variable, but the same name. We can store indexed data in using the same name. So if we wanted to, for example, store multiple grades, before we have arrays, we have to first know how many grades we want to store. And secondly, well, this is if we're going to store them for any extended period of time. I think the current assignment that's due, I'm losing track of time. I think this is the one that's due next class, next Monday. Is the grades one?
No, the next one's due.
Where'd I get grades from? Is it grades the one that I'm supposed to be grading this weekend? Okay, so I don't have to worry about it. So grades is on the midterm?
8, yeah.
Grades is 8 on the midterm. Okay, cool. So I can talk about it. So question 8 on the midterm. Question 9 was quadratic.
No, 7 was the pseudocode for grades.
Okay, pseudocode for grades. Yeah, okay. So there was something about grades on the midterm. We didn't have to write Java code for it, I guess. So we didn't, in order to compute statistics on grades, we really had no way of storing an arbitrary number of grades in memory. So you had to keep running totals or running averages, running sums. I don't think I specified what statistics were, but now we can say something like, how many grades are you going to enter? And if I say 12, I can create an array of size 12 and then insert grades index by index. So let's do that. Let's get rid of this int. Let's say, I guess at some point I'll need a keyboard. Might as well get that out of the way. I need a keyboard that puts the right key right under my finger wherever I'm going to type. Adaptive typing. There we go. Okay, so we have a scanner.
Somebody's squeaking. How many grades? I'm actually going to change that to just a print. So I could store the number of grades that get entered directly in a variable and then use it to create an array of that size. But instead I'm going to combine both statements into one line of code. Int array of ints. Let's call this something more reasonable. Int grades. Grades can be doubles, so we'll make it in a double. Create a new array of type double with size scanner.next double. Or I guess that should be keyboard since that's what I called it. And here, my next prompt will be enter grades.length grades. So if I type in 12, it'll say enter 12 grades. Let's see. So when we use arrays, for loops are really handy. And by really handy, I mean I wouldn't even consider using a while loop when I'm dealing with arrays. Because for loops have several upsides. First of all, I want to go through every element in this array and change its value. Which means I want some number that represents the current index into the array that I'm changing. And for loops have that pretty much built in. You have an initialization, an approach, and some comparison. And with arrays, after you do this for a while, you can pretty much stop thinking and just type. Start at 0, because array indexes start at 0. Most humans start counting at 1. Most programming languages start counting at 0. The reasoning for that is that it's very easy to represent 0 in computers. And if you started counting at 1, you would end up with a possible representation that you could store in this case, an int that just wasn't used. That's not very efficient. So the range of an int is 0 to, well, it's negative 2 billion something to positive 2 billion something. In this case, we're starting at 0 and going to potentially 2 billion something. So we get that extra index. Another upside to array indexes starting at 0 is that the index of the last element in the array is 1 less than the size of the array. So if we have an array of size 8, like I had before, the last index of that array is 7. The first element has index 0 and the last one has index 7. So I can use a strictly less than comparison here and say if my I is less than the length of the array, that means I still have a valid index. So grades.length, and the usual I++, lowercase I++.
So that brings us to our next question. How do we index an array?
The syntax is very similar to everything else that we've seen that deals with an array. It's the square brackets. In this case, it is the identifier, which in this case is grades, followed by square brackets, and inside those square brackets goes the index of the element we want to access. So if we're iterating through these elements and we have I usually stands for index, iterator, something that starts with I. There are plenty of possibilities. We can just use I as the index into our array. So that means the first time the loop is executed, I is 0, grades brackets 0, sometimes referred to as grades subscript 0, grades sub 0, grades 0. Programmers find lots of quick ways to say things. Grade sub 0 is the first element. The second time the loop is executed, I is 1. Grade sub 1 is the second element in this array. The last iteration before that condition fails, I will be, well, I haven't entered anything for how many grades. But let's say I enter 8. I will be equal to 7. Grade sub 7 is the last index of the array. Then it will be incremented. It will be 8. It will not be less than grades.length, and I've filled everything in the array. So it lines up perfectly. And what am I going to put in this array? Keyboard.next. I was jumping ahead of myself here. This should not be a double. This should be an int. You can't have a fractional length of an array. You can't have 3.4 elements. It doesn't work. And I think if I'd left that, it should have been a compiler error. So at this point, we have a bunch of grades in the array. But we're not actually doing anything with that. But we can demonstrate that it does run and doesn't crash. How many grades? 3. Enter 3 grades. 84, 92, and 99. And it's done. No crashing. It ends when it's supposed to. The loop only executes 3 times. Perfect. I've talked about for each in here, right? Briefly. I think I mentioned that there are collection-looking things, and I left it at that. So there is this for each syntax. It's called for each, even though the word each doesn't actually appear. The syntax looks something like this. We'll call it G in grades. And it's usually pronounced for int G in, the colon is pronounced in grades. And the basic syntax is for some variable declaration. That's essentially what it is. It's a type followed by an identifier. The identifier refers to what name you want to use to access that particular element inside the body of the loop. And each time the loop body is run, it refers to a different element. On the right side of the colon, it is something collection looking, something that has multiple things in it. Arrays work really well for this. There are also some Java classes that this works on. But for now, I think the only useful thing we have that this could work on is arrays. So you can write code as if the syntax is for some scalar variable declaration in some array, and then your loop body. In this loop body, let me fix my braces here. I was writing C# all morning, so slightly different convention. Let's print out the grade. Right, they're not ints, they're doubles. I'm using the same numbers as from the previous run, and it prints out 84, 92, and 99. So in addition to that, let's so comment on the question that was on the midterm. Since it was pseudocode and the point of that question was here's a problem, how are you going to solve it? There are multiple different ways to solve that problem. You could have pretended that if you knew that arrays existed in other languages, like those of you who took my Visual Basic class, or have programmed in other languages or even in Java, you could have pretended that arrays existed and said, I don't know how to use an array in Java, but I pretend that there is some construct that holds a collection of data. That would have been one way to solve the problem. The other solution that I can think of right now is the one I mentioned before, where you kept running statistics and gradually computed them based on the next grade that was entered. Given the knowledge that you had at the time, that solution used more of it, or more of the problems that you ran into in solving that problem were answered by things we'd seen in this class. I hope that wasn't too confusing. So now we have, by now I mean at line 19, we have an array of grades that is fully populated. And we can compute statistics on it. Quick note on the differences between Visual Basic and Java for those of you who have taken the Visual Basic course. There is no redim in Java. It doesn't exist. There's no easy way to lengthen an array or shorten an array. You have to do it all manually. There is actually a helpful utility function called system.arraycopy, and this method's name does not follow the Java convention. The C should be capitalized, but it is not. It takes 5 arguments. This is not mentioned by the book, I don't think. This takes 5 arguments, which is a source array and an index in the source array to start at. So if we were, for example, making an array larger, we would start at 0. The destination array, and if we're making it larger, the index into the destination array where we should start copying these values should probably be 0. And then the number of elements. Obviously, I don't have those variables, so that statement won't combine. But it's there. It might come in handy sometime. That's basically Java's answer to Visual Basic has redim and we don't. Okay, so back to purely Java land. Let's compute some statistics on this array. Let's see. Let's start with my least favorite. Standard deviation. I absolutely hate the standard deviation, and it's mainly a philosophical issue. That n-1 in the denominator makes absolutely no sense to me. It's been explained to me multiple times, and statisticians' favorite explanation for that is because it's oh geez, I've forgotten what it is. It loses a degree of freedom. As far as I'm concerned, degree of freedom is axis of rotation, axis of movement. These numbers aren't moving anywhere. There's no degrees of freedom. The other explanation I've heard is that the number comes out being more accurate. Okay, that's an empirical explanation, fine. I can accept that explanation. I don't like it, but I'll accept it. So for this, we'll pass in the actual array. Which brings us to the next point. How do we pass an array into a method? Just like we pass any other variable into a method. I really don't know why books go into make an entire section about that. It's no different from any other variable. We have a name, an identifier, and we can pass it into a method exactly the same way as we would any other identifier. There is a little bit of trickery, I guess. If you want to pass an element of an array into a method that accepts a scalar, so for instance, system.out.println, if we wanted to print out the third element of the grades array, assuming it exists. We should check first, but the third element would be index 2. Is basically that. If you have an array of type int, each element is an int scalar. In this case, we have an array of type double. An array of doubles. So each element is a double, is a scalar. So it's no different from if we had created a double variable, a variable of type double that contains one value, not an array, and passed it directly into system.out.println. No difference whatsoever. Okay, so here we have. We're calling a method that doesn't exist yet. We're passing it an array of doubles, and it looks like we're expecting some return value. That should also be a double, just because we know how standard deviation works. So let's create a method to do that. Static double standard deviation double. We'll stick with the statistics language. Samples. So I just realized that I don't think statistics is actually a prerequisite for this class. So is anyone not familiar with the standard deviation? Okay. Is anyone here not familiar with the average? Or, right, the mean. Oh geez, I've forgotten my statistics. The average. The sum of everything divided by the number of pieces. So the standard deviation is basically no statisticians in the room, right?
Just one.
Okay, so don't hurt me.
I will.
This standard deviation is basically the average of differences from each sample from the mean. So if the mean of a bunch of grades is 70, which is in theory what it's supposed to be, the difference between the mean and, say, a 90, a sample that is a grade of 90, is 20. And then we have a bunch of other differences. How far away each sample is from the sample mean, or the overall mean. We average those together, and that's basically our standard deviation. I didn't murder it too much. Did I? Cool.
Good job.
And that's when we write the formula. That's essentially what it'll look like. Which, through that explanation, it means that we need to have the mean. We need to compute the mean somehow. So it's using top-down programming concepts. Pretend that we're going to write later on a method called average. Okay, so now we have the mean. I think the easiest way to do this is probably to go through samples one by one and compute the difference, the distance from the mean. That is called the sample variance, correct? Okay.
You're doing it. You're probably a long time.
Okay. So double running sum, and that will start out being 0. There's a square term in here somewhere. I'm trying to remember where it is. I'll actually call that running numerator. There is a fraction in here somewhere. And that ends up being the numerator of the fraction. So I mentioned we have to go through each element in samples. And since we're not changing the value of samples, we can actually do that for each thing. So for double S in samples, running numerator equals, here's where that square term comes in. So we'll handle that first. We're squaring something. And the thing that we're squaring is this difference between this particular sample and the overall mean. So S minus mean. It doesn't really matter which order we put S in mean because it's getting squared anyway, so it loses any sign that it had. The result of that will always be positive. So at the end of this loop, running numerator should be some sizable, I'm not going to say large, but some sizable positive number. That's the complicated part of the standard deviation. The rest of the equation is dividing it by that n minus 1, the length of the number of samples minus 1, and then taking the square root of the whole thing. I think I have those in the right order. I hope.
Sorry, I wasn't.
Division by n minus 1 and then the square root?
Yes.
Okay. Right, so we'll say return math.pow something that I'm going to compute and 0.5. That will accomplish the square root. Or let's do it a simple way. Math.square root. What am I taking the square root of? This numerator divided by n minus 1. What is n in this case? Samples, not length. And because of I don't know what, there's the minus 1 in there. So that should work. Now we need some way of computing average. So, and this should be relatively easy. So I'm going to quickly implement this and not give much explanation for it. I'm having serious difficulties typing today. Right. That looks like a proper implementation of an average method. And this should compile. We'll run it, give it the same values I've been, well, if I can remember. Was it 84 or 86? Let's say 86. 92, 99, and there are our grades 86, 92, 99, and our standard deviation is 4.7. And that sounds about right. Our range would be, what is that, 13? Half of that is 6.5. So 4.7 sounds right. Can also print out the average grade. $92.3. I think that's probably sufficient for demonstrating arrays. Some other cases where we've used variables where I haven't demonstrated we can use arrays, but we can still use arrays. are as instance variables. So we've seen arguments to methods, parameters to methods, arguments to methods, local variables, which is what I've been declaring so far. You can also use them as instance variables. You can use them as parameters and arguments to constructors. You can use them pretty much anywhere you can use any other variable. You can even use them as this part of a for each loop. But in order to do that, you need a multi-dimensional array, basically an array of arrays. If you have an array of arrays or a multi-dimensional array, each element in the top-level array is itself an array. So if you were going to use a for each loop on a multi-dimensional array, each element would itself be an array. So for something like that, you could have, now this bit of code isn't necessarily meaningful, but it is syntactically correct. And in this one statement, we have a lot of new things. So I've already mentioned multi-dimensional arrays. How do you instantiate multi-dimensional arrays? Exactly the same way as you instantiate one-dimensional arrays, just with multiple sets of square brackets. All dimensions need to be specified. You can't leave a dimension unspecified because Java still wouldn't know how much memory to allocate for that array. Each element in the top-level array is itself an array with one fewer dimension. One fewer dimension. That sounds bad, but I think it's grammatically correct. And in this case, the top level of the array is specified by the first index. So in this case, we have an array of 4 elements, each of which is an array of 6 int elements. So you can think of this as a 4x6 matrix. However, one thing to be careful of is that you can't specify the, if you think of it in row major order, if you think of the first index as denoting a row, you can't specify a column and get an array of values that all fall into that same column. Does that make sense? Correct. You can't, so in MATLAB you can do something like, I haven't used MATLAB in a while and I like that, but you can't do something like, MATLAB's all parentheses, right? It's gotten worse since I've used it. Okay, so matrix. In MATLAB, you can do something like that, and that gets you the 4th. That gets you something valid. That gets you an array. Can't do that in Java. Obviously, that syntax is wrong, but you can't do that and expect it to give you an array. That doesn't work. You can, however, do that, and if it's a 2-dimensional array, it will give you the array at index 4. So there are some nuances when it comes to multi-dimensional arrays. I think multi-dimensional arrays probably make more sense when you start treating them as data structures, so you can abstract away the functionality of the multi-dimensional array if you want to treat it as a matrix. In a previous class, not here, but in a previous class that I taught, I did give an assignment where the task was to take a multi-dimensional array and wrap it in a class that made it behave like a matrix. So you could say my matrix.row 4, and it would get you the 4th row. And it didn't matter how you stored it, whether you stored it as row major order or column major order. It got you the right row and column. You specified the number of rows, specified the number of columns, and it was basically a data structure. What else? You can also have something called ragged arrays. This book calls them ragged arrays. I've seen them called jagged arrays too. Basically, a true array of arrays. So, what I have there, new int 4,6, looks a lot like a 4x6 matrix. Each subarray has exactly the same number of elements. But Java treats it as an array of arrays. So there's nothing to prevent me from, I'm actually going to deconstruct this a little bit and save this somewhere. So int multi-dimensional array. There's nothing to prevent me from saying this third array should actually be a new array of size 17. Compilation succeeds. I can also create a multi-dimensional array, another multi-dimensional array, as oh geez, I think I can do that. I can. I don't use this very often. I don't know if there's a... I can't think of a use case off the top of my head. I've never done this except in a class. So, that basically says allocate just the top level. AMDA, another multidimensional array, is an array of size 4. Each element will be an int array, but I haven't assigned those yet. Then I can go through and say, if I spell it right, the first subarray should be a new array of size 6. And then you start copying and pasting. And rule of thumb when it comes to copying and pasting, if you start copying and pasting, there's usually a better way to do what you're doing. And that gets you a jagged or ragged array. The first subarray has 6 elements, the next one has 7, the next one has 8, and the next one has 9. I could just as easily specify this array, even though it's rectangular, just like this, specifying 4 as the first index here, leaving that one blank, and then for 0 through 3, just creating new one-dimensional arrays with 6 elements each. But depending on the size of your arrays, line 23 can be a lot more compact. Questions on arrays and multi-dimensional arrays? Cool. So I'm going to get rid of all of this stuff. And let's create a method called sort. Actually, before we do that, it's kind of irritating to be typing in all these grades every time. So one thing I could do is hard code them, but another thing I could do is take advantage of this thing. We've ignored this, the string args to this point, but now we can tell that it looks remarkably like an array. It's because it is an array. It's an array of type string, and it doesn't always have the same length. And the question is, where does this come from? Main, obviously the method. The string args is a parameter to this method, but we never actually call main. So we never have an opportunity to create string args. That's not entirely true. We know that main is the entry point to our program, and basically that means that Java automatically calls main. It looks for a public static void method called main that takes a single variable of type string array. Doesn't matter what that string array is called, because that's a local variable local to the method. But it looks for a very specific signature. And when it calls that method, what it passes in is the stuff that is on the command line. So you notice that when you click run, Dr. Java puts this run and then the name of the class at basically its prompt. This is kind of Dr. Java's way of handling the command line arguments. In the very first chapter, the book talks about how you would compile Java programs if you weren't using something like Dr. Java, and how you would execute Java programs if you weren't using something like Dr. Java. And it's all through command line tools. This interface, the interactions pane in Dr. Java, gives kind of an abstracted interface to that sort of thing. So we don't have to worry about compiling, running, but if we wanted to pass command line arguments, this prompt allows us to do that. So we could say this, we could actually say this is a command line argument. I think that'll work. Yep. We don't do anything with those command line arguments. Stop. Reset. Where's reset? Oh, right there. Hiding. Yes. So let's actually use that. And that means I'm not going to get use any keyword input at all. I'm going to use this string args essentially directly. So the interface to this program will be every command line argument will be a grade to process. So I don't need to specify a number of grades to process because args has some length. The length of args is the number of arguments that I've supplied. So we can actually change this to, I'll comment this out and copy it so you can see the comparison. Oh geez, I'm not on Windows. So instead of keyboard.nextInt, I don't have a keyboard anymore. So this should be args.length. Has anyone programmed in C or C++ before? Or I think Python behaves this way too. Pretty much every language other than Java. Okay, good. I don't have to cover that difference. Actually, I might as well for completeness. In all of those other languages, the first command line argument is taken to be the name of the program. In Java, that's not the case. The name of the program, in other words, the name of the class file that is executed, it is not considered a command line argument. It's only stuff on the command line after that. So if I had this, args index 0 would be 6. In all of those other languages, it would be args index 1, because fun with arrays would be index 0. So args.length should be the length of our grades array, and that for loop is okay. We just need to change the body so that instead of getting a number from the keyboard, it gets the grade from the command line. We can use this index I for the index into the args array as well as the index into the grades array. But this presents a problem. Args is an array of strings. Grades are doubles. The book specifically talks about how to deal with arguments that are integers. On page 507, mainly on 508. It was in there somewhere. I saw it earlier. Yes. Middle of 508. You could use integer.parseInt and pass in an element of the args array. That would give me an int, and it would break horribly on doubles. Luckily, there is... I'm doing this from memory, so I hope this is right. An equivalent function or method in the double class called parseDouble. And the way to find out if I'm right or not is to pull up the API documentation. Scroll down to the double wrapper class, which should be around here somewhere. Double. And see what it has. Methods. We want static. We want static methods. long bits to double. No, that's not it. Parse double. Yes. Returns a new double initialized to the value represented by the specified string as performed by the value of method of class double. What that means is basically takes a string in, spits a double out. So that should work. And then everything else just uses that grades array. So we know all that should work fine. However, running it with no arguments means that our standard deviation is -0, which is kind of odd. Yes, in double representation there is +0, -0, positive infinity, negative infinity, and not a number. Because computers can get values like that sometimes. The reason we get -0 here is mainly because mean returns not a number. So we have some in our equation we have s minus mean, which is some number minus not a number. Which I guess ends up being -0. And the mean returns not a number because we're dividing by 0. We initialize samples to be an empty array. It doesn't have anything in it. So 0 divided by 0, actually a non-zero number divided by 0 results in a division by 0 exception. 0 divided by 0 is not a number. And sometime during this class, since we're dealing with math that doesn't really make the WAT video, WAT. Right. So, however, if we specify some grades like we did before, 86, 92, and 99, we get the same numbers that we got before. I'm going to comment out this for loop. So we have shorter output. In the interactions pane, to get to the previous command I executed, I press up, the up arrow, so I don't have to remember what I typed to type it in every time. So we still get the same standard deviation and mean. So let's write that sort method. And this, what sort do they? Believe it or not, there are multiple different ways to sort numbers. Selection sort. Okay, cool. Selection sort, in my opinion, is the easiest sort to implement and the easiest sort to think about. So the optimal sort to start with. So we'll write a sort method. Public static void. Selection sort is what is called an in-place sort, which means that we can operate directly on the array that contains these values. We don't have to create another array and copy values from one array to the other, though we could if we wanted to. There's nothing preventing us from doing that. But selection sort has the nice property that we don't have to. And if you recall from reading the book, the basic idea behind selection sort is that we find the smallest, the lowest value element in an array,
swap that with the first element in the array. Then, ignoring that first element, find the smallest element in the remaining part of the array and swap it with that second element. Then, ignoring those first two elements, we do the same thing with the rest of the array, swap that with the third element. Go through the array, and once we get to the second to last element, we know that the last element can't possibly be any smaller than anything before it, so the array is sorted. So what does that look like in Java? It looks like a double for loop. And we can say I going from how many times do we have to scan the array for the smallest element? That value is the number of elements in the array minus 1. Because we don't have to scan through the array that last time because there's only one element in that array. And an array of 1 is by definition sorted. So I equals 0. I is less than, what did I call it? Nums.length minus 1 and I++. There are actually two ways to do selection sort. You can either look for the largest element and place it at the end of the array, or look for the smallest element and place it at the beginning of the array. The two are identical. The usual strategy is to look for the smallest element and place it at the beginning of the array. So on each of these iterations, we need to find the smallest element. So that means that it means we need to find the smallest element in the part of the array that is not yet sorted. So we need another for loop to search through the array for this element. And that means we have to start at the index I. The index I represents the first element in the unsorted part of the array. So on the first iteration of the outer loop, the unsorted part of the array starts at the very beginning of the array. On the second iteration, we know that the smallest element is in the first slot in the array, so we can start at index 1, and so on and so forth. Well, j is less than nums.length, because it's possible that the smallest element is the last element in the array, and increment j. In order to find the index of the minimum element, we need to hold on to some data. We need this is a double array, so double min, which is the minimum value in this part of the array. And we need something that we'll call argmin, which basically means the index of the minimum value in the array. We'll need this argmin later on toward the end of this loop when we actually do the swapping. And we can actually initialize these. We need to initialize these to something that makes sense. In this case, since we're dealing with grades, we can assume that no one has a negative grade. Or, no, that would work with max. We can assume that no one has a grade over, say, 999. But in the general case, we can't really assume that. But we can assume that the smallest grade will either be the smallest
element will either be the first element in this subarray that we're looking at, or somewhere else in the array. So we can initialize min to nums I, initialize argmin to I, and then this loop only needs to check to see if any of the other elements are smaller than this first one. So we can change that to I plus 1. And in that case, if the ith element is the smallest element, the loop will go through, not find any smaller elements, and it won't make any changes to I. Otherwise, we'll have a new smallest element. Which means that inside this loop, if the current element that we're looking at is smaller than what we think the minimum is to this point, so if nums j is less than min, we found a new minimum. And that means we have to set min to nums j, and we need to set argmin to j. Questions so far? We haven't quite completed the sort, but we're almost there. So at this point we have the minimum value in the array, and we know what its index is. So now we can perform a swap. We can start by saying if the smallest element in this subarray is already where it needs to be, we don't need to swap it. That would be inefficient. So if j does not equal, no, if argmin does not equal I, then we swap. How do we accomplish a swap? We could write a method to do it, and then implement that method, but it's 3 lines of code. These are doubles, so I'll create a temporary variable, and save in that temporary variable nums argmin. Then I'll put into nums argmin the value at nums I, and finally put into nums I the value that I stored in temp. That is the complete implementation of selection sort. I will go back to it in a second. Just I'll do that. I just want to put this bit of code here so that this time I will type in values that are not sorted and demonstrate that it sorts the array. So let's what's the most unsorted I can make this array? Reverse sorted. So let's do exactly that. 99, 92, and 86. And we can see that it sorts. Remember that because an array is a reference type, it is the thing that's passed into the method is a reference to whatever's actually being stored in memory. So if I follow that reference and change something in it, it is changed no matter where that memory is referred to. So I'm changing the values in some of these array indexes inside the method. That's reflected outside the method. So any questions on arrays, on sorting? I didn't talk about searching. Let's see what the book actually says about searching. It talks about linear search, which it calls sequential search. That's basically, look at the first element. Is it the element I'm looking for? If no, continue on to the second one. Is the second element the one I'm looking for? If no, continue on to the third element. If any of those is yes, say, yes, I found the element. If you get to the end of the array and the answer is still no, then the array does not contain the element you are looking for. Any questions? So I ran a little bit over time, but we'll take a 10-minute break, reconvene at 12:23, and we'll watch the WAP video.